Let's go to here. It's already streaming.
So
Okay.
let me check.
Uh-huh.
There's a little echo.
Yeah. Maybe because we both are with the microphone, but yeah, it's already in YouTube, right?
Yeah, yeah,
Okay.
it's right.
So, hi everybody. Today we'll talk about servo motors. Rodrigo. Hey, Rodrigo.
Hi, Alan. Hi, guys. Nice to
Rodrigo.
be here again.
Yeah, nice to get you again here, Rodrigo. And today, Rodrigo will present about how to control servo motor uh, using PWM on NuttX, right?
Yeah, that's right. So can we start doing the theoric part? So
Right.
then I go to the parts.
Yeah,
Okay,
I will explain a little bit about the theory and then you show how you did it, okay?
perfect.
So, to control servo motor, you need to use a PWM pulse similar to this one. So you have a period of 20 milliseconds. That means in 1 second we have 50 cycles like this one, like this waveform. And here we control the that cycle. Sorry, the Dutch cycle means how much time the pulse will be in high level compared to how much it will be in low level. So with control this length, we can move the position of the shaft of the cursor. Let's put this way of the servo motor. So if the minimum pulse is uh, zero point 0.5 milliseconds, it will be 0 degree. And if it's 1.5 milliseconds, it will be 9 degrees. 90 degrees. And if it's 2.5 milliseconds, it will be 180 degrees. So it means we modify the pulse length only 2 milliseconds, from zero point 0.5 milliseconds to 2.5 milliseconds. So basically that's it, the theory about servo motors. And these servo motors is normal find in aero models and other small robot toys, and they are very common um, and low cost for makers, for example, to use it. Okay, I think that's enough, right, to get
Yeah,
a
perfect.
theory.
Hmm.
And now I will move to you. So you are
Okay,
presenting, yeah.
okay. Just let me see if okay. I'm seeing already my. So what I'm showing here is the schematic
Mm-hmm.
for our board, right? So this is the schematic for the board that I have been using in this series of the tutorials. So here, I don't know exactly when, but some time ago we did a presentation regarding the DAC, digital to analog converter. And at that time, we used the PWM to show that. And so we're going to use this code and just show how to control the servo motor with the same code, okay? You can see here that in PA6, we have the PWM2 here. It's connected to our DAX circuit here, but there's a jumper that's open for this experiment, okay? So in fact, both of these are open and we could use PWM1 or 2, but I choose the PWM2 here. And so this is open, and this same pin is exposed in your connector here. I think in the pin 7 here. Okay, so that's what we're using for control the server. So the code will be the same, and just showing the hardware that we have opened this jumper here, so we can use the PWM here. And okay, so that's for the hardware. Maybe is a good time to show you guys uh, what you have here. So I think it's a little difficult to see. Let's see if I.
It's okay. I
Uh,
think we can see clearly here, Rodrigo.
yeah.
You
Okay.
you are using the
Oops.
PWM2 or slash PA6 pin, this
Hmm.
orange wire,
Yeah.
correct?
Yeah. Yeah.
And
We can see.
yeah,
Yeah. That's perfect.
and you are uh, powering up the server using GND and 5 volts, I think, because the
Yeah.
3.3 is this side, but the other side
Yeah.
is 5, correct?
That's right. Yeah.
Yeah, 5 volts.
Mhm.
So,
Yeah. Okay, so let's just review very quick the code that we did for the DAC, so we can remember that.
mhm,
Okay, so here in our board, so we're still using this STM32F4-RS485, right?
mhm,
So we have here the STM32 PWM.c that has the code for the PWM. You can see here that you have the setup function that will initialize the PWM and then register the PWM at /dev/PWM0. And on bring up, we are going to call this. If the config PWM is enabled, we can call this, right?
mhm.
And I think, uh, okay, let me see. I think you can see here. So for configurations, we already have some. As I said, you're going to use the same as DAC. You can see here DAC, right? So we have the examples PWM, the PWM itself. You are using the timer tree, channel one, and saying that channel one is out.
Mm-hmm.
Okay, and I just want to show you the pin. I think it's in this. Okay, it's here. Okay, so you have a device here that this STM32 for F400 has no real PWM, so we're using uh, the timer tree on channel one on
Mm-hmm.
or PA6 or P yes PA6, right?
Yeah,
That's right.
PA6 pin.
Yeah. And okay, so that's the pin configuration. What else do you think you can show here for the guys regarding
Yeah, I
the
think
software?
basically that's it, because also if someone has some question or some doubt about how to configure PWM, they can go uh, to the DAC video that we record
Hmm.
some years ago, some time ago, months, and
Yeah.
he can review all the configuration. But basically, you show the most important, the PWM initialization code in each file. You have it,
Hmm.
the pins that we are using, the kconfig configurations that we need, config STM32 PWM,
Hmm.
config PWM, and also the PWM example, right?
Yeah.
Yeah.
Okay, so just to okay, so let's go to the Prats. So I'll remove here for now the code.
Mm-hmm.
So I will start clean, right? So start this clean.
Dash J to be fast.
Okay, yeah. Okay.
Mm-hmm.
Now you're going to configure the deck. So as I said, it's the same configuration as deck. So
Yeah.
just reuse on that.
Yeah, just to remind people, as you already said, but just to remind, it's not real DAC because our board is using PWM to emulate or simulate a DAC. So we
Hmm.
control the final voltage, use PWM pulse.
Yeah. So here we're going to build our firmware. Okay.
Hmm. Yeah, and yeah, it already has some others application as well, like buttons,
Yeah, yeah.
not
I
only
think
PWM.
we used the buttons in one of the first uh,
Yeah,
lives in Bring Up, and then
yeah, probably we reuse it, and
yeah.
it was still here in the PWM example.
Hmm. So I put the device here in ultra mode, right? So we did this a lot of time. Oops.
Mm-hmm. Yeah, if you want to put the camera now,
Oh, sorry. Yeah. Let's put here. Okay. And sorry, I need to
yeah,
find a way to fix
yeah,
this kind
no,
of thing. But
it's okay. We can see the motor and the board.
okay.
Yeah.
So now the board is in DFU mode. So we're going to use DFU to flash. We did this a lot of times already. So you guys already know how to do.
Mm-hmm.
And okay, let's reboot the board, pressing reset.
Mm-hmm.
And here yeah, assessing. Okay, so we have the shell here, the shell. Let's first see if they included our
Yeah,
application. It's here,
PWM.
the PWM. Let me do something here. I will kind of, let's see,
Yeah, on top. I think yeah, in the middle. Yeah.
always on top. Okay, so now we can, okay. And let's see if the drive was registered as expected. So
Yeah, we have
yeah, we
PWM
have
zero.
here,
Yeah,
it's
PWM
here,
zero.
right?
Mm-hmm.
So let's play with it. So the just showing the PWM help. I think PWM, no,
No,
dash 8, right?
yeah, dash 8.
Okay. So we can pass the path. The default is already the one that you are using.
Mm-hmm.
Uh, we are going to pass the frequency,
Yeah.
50 hertz, as Alan already explained the theory. The Dutch cycle, that's what we change to move the 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 servo according to the that cycle, right? And
Mm-hmm.
the duration you're going to pass 1 second. So let me do that. So PM down. Okay, I try not to pass the dev path for now because
Mm-hmm.
the flow is the same. So the frequency is 50.
Right. The
I
Dutch
put the
cycle start, I think, with yeah, the duration first. Maybe
yeah,
1 second is enough.
I put that cycle in the end so I can copy and
Yeah,
paste the comment.
yeah, good idea.
And that cycle for starting, I'm going to use
10%,
uh,
right?
10% is 180, right?
Ah,
Degrees.
y- yeah. It's difficult to remember. Yeah. Um, let's see.
Uh, I had a annotation here. I think that's it. Let me check. So uh, is a good
Because
time to take a look in
yeah,
the.
t-
Okay, go
10.
ahead. Sorry.
Yeah, just to remember because the Dutch cycle it be a percentage not over the frequency but over the period that is 20 milliseconds. If you
Yeah.
pass 10, it will be uh, 2 milliseconds. So we want 0 point. It will less than 10, right?
Yeah. So 10. would be uh,
200, yeah, this one.
this one here.
Yeah,
I think like
yeah, you need to pass
five,
less than 10. 5,
five
5 will be the
percent
0, like
zero,
the initial.
and about 7.5 will be this 90. I think that's the.
Yeah,
So let's start by doing five, right?
yeah,
Five here. Okay. Take a look on the motor.
yeah, it's move
Okay.
just a little bit.
I'm not sure if it was possible to capture because
It was
maybe the
fast, right?
the
Yeah.
camera. But let's try other. So let's try now.
Try to pass 10 so we can see it more clearly
Mhm.
deflecting.
Okay.
Yeah, this way. Good. Very
Yeah.
good.
And
Yeah,
now I go back to the five,
yeah,
so
it
you
will
can
return
see.
to previous position.
I will just
Yeah, keep it instead.
okay,
Yeah,
very fast.
very good.
In fact, it's not that it's too fast. It's because maybe the frame rate that the camera is capturing is not so fast.
Yeah, but it's good.
So let's try to put the 90 degrees. That should be something about
Yeah, a little bit.
7.5. Not sure if they
I don't remember if
okay.
that's a point.
Yeah,
I think it's
I do
only.
think so.
Yeah, I think it's
Let me.
only
Yeah.
integer.
Okay.
Yeah,
So yeah. So uh,
yeah,
like if so this so we talk about these four angles like here, right? So
yeah,
uh, so
yeah,
90, 0, and 180 and 80. But if I pass like instead of five, I pass six. Uh,
yeah.
I do think that they will.
They will move a
Uh,
little bit more to
mhm.
near the horizontal position.
Yeah.
Try to pass 6, for example.
Okay. Let's do that. So six. Yeah.
In the other
Yeah.
direction.
Yeah.
Yeah,
Maybe
that's okay because 5 it is like in the
that's
vertical
five. Yeah.
compared to the screen. Yeah,
Yeah.
exactly. And it
That's the zero, right? That's the zero. So uh, yeah.
yeah
Well,
that
I think that's it.
yeah from here we can see that we can control the position. I don't know. Maybe you can just do a test.
Mhm.
For example, try to 5.5. Let's see if a little bit move between 6.
Okay.
Let's see if
I
you
eyes on the motor. Okay.
let's see if you
Let's
change or
go.
not. Yeah, I
No.
think it's not getting the fractional point. It's only
Okay.
yeah. Try
They
no
ignore. Okay.
yeah. Try 6. 6 we already did, but you can go like in sequence.
Six,
6,
uh,
7, 8, 9, and
seven,
10. Yeah,
eight,
8, 9,
9,
and 10.
and 10.
Yeah,
So basically, you can start in five and go away until the 10. But more than 10 is, I think, it's same as 10, right? They
I,
will not do. Oh no, they can do.
I think they can because it is 180, so it can still moving.
Mm, and 13.
Yeah,
Okay, I read. Uh, almost did a complete turn, right? So
yeah, almost.
that's the limit.
Yeah,
Yeah,
and also you can try less than 5. Try 4.
four. Okay.
It turn.
Uh, it's started, but in fact, man, that let me try do something here. Okay, maybe if I could get a
And
just
also, Rodrigo, it's important to say this we are using the PWM application, but if someone wants to create the application, they have more control over it because in application we cannot pass intermediate values, not fractional
yeah,
values. So
yeah. I'm trying to find
hmm.
a way to mark here.
You do have some pencil, some sharp that
Yeah, that's I'm trying to
or if you have some color adhesive, like in Brazil we say Durex. If you have adhesive, color adhesive, you can use it, or like Scotch tape or other.
post it, right?
Yeah.
Let me try this. Not sure if you, because, okay, let's try to see if, I think the post-it is not, okay, give me a second, please. I will be back.
Hmm. Sorry for the noise. Someone sent message. Alison is sending message here because I asked him to verify in YouTube, but um, okay.
Okay, I'm going back.
Mm-hmm.
I, okay, I'll make a mark here.
Yeah, I think Rodrigo, the value should be from, in theory,
Hmm,
should be from.
not
Okay.
so good. Not
The,
so good.
yeah, it's not so good to see, clear to see
Yeah,
here.
okay.
No, no problem.
I think I need that pen that
Eh,
writes on DVDs in the old time.
yeah, if you have,
It's a
yeah,
plastic and
or skate, fita isolante, Scotch tape.
that would be
Yeah, I think it's better because it's black and easy to see.
okay. Last attempt with this. No, okay. I got my tooling box. Just a sec.
I don't know, Rodrigo. I think it's okay.
Hmm,
We already saw
okay,
the theory. You don't need to spend time with it.
okay. That's
Yeah.
okay.
Okay.
The guy's trusting us, so
Yeah, you are a reliable person, so
so,
we know it's working. Yeah.
so you can see
Yeah, you
a
can see.
little.
Yeah, on blue. Yeah, and yeah.
Okay,
Try dash D2, for example. Let's see
okay. Let
if you turn a little bit more or not.
two. No,
No. Yeah, I think it's four or is the limit.
five.
Yeah.
Let's go again. 5, 6. You can see we're running 7, 8, 9, and 10.
Yeah, and I think the mass limit is 13 if or
Yeah,
14 if I'm not mistaken.
11, 12, and the
Hmm.
last one I think is 13,
Yeah,
and 14 will not turn anymore. Yeah,
yeah,
that's
exact.
it. So from
Yeah,
5 to 13.
yeah,
Okay.
very good.
Yeah.
Nice demo, nice presentation, and So thank you very much again for doing it and help to create this nice presentation about the servo motor control. And I hope
Thank
it
you.
be useful for other people.
Sure. And so thank you, Alan, for all the mentoring and the help on my journey in the NuttX.
You are welcome.
And so let's continue. Maybe next time I can bring a different sensor. I have
Mm-hmm.
some ideas here,
Yeah,
and let's try to keep the pace as well because last month was a crazy month for me. It was difficult to have some time.
yeah. But
Let's try to keep the pace. That's important for YouTube algorithm.
yeah, cool. And thank you very much and have a nice weekend.
Thank you, Alan.
Thank you
Bye
guys.
bye.